Hello everyone. I wanted to work this problem from the tail section of 1.6. It's one of the harder ones in the problem set, and the assumption I'm making here is that you've worked your way through the problem set and you're getting proficient with the easier ones, and you might want to see a more difficult one. And in addition to that, there's going to be one of this caliber on the midterm as well as a few easier ones. So I'm going to work this one. If you want to stop the video here and work it yourself, go ahead. First thing I want to do though is do a quick survey of what's called the laws of exponents. Now, the textbook is not currently calling 1, 2, and 3 here the laws of exponents. Um, by the time we get to page 440, Bittinger and Ellenbogen will call them the laws of exponents. And indeed, in math education, if you were to do a Google search on the laws of exponents, these things would all pop up. This is the standard term, and these are the 3 standard laws. And the first one here is when the bases are the same and you're multiplying, you end up adding the exponents. The second one is when you're dividing and the bases are the same, you end up subtracting the exponents. I want to reinforce that with a little mnemonic here, a mnemonic device. Namely, the division bar looks like a minus sign. And so what's going to happen here is you're going to have 3 minus 2. And this is a critical idea here, these circles here, because when you have negative exponents, what happens is you generate a double negative. And I see a lot of people falling down on this particular law. Fortunately, the problem I'm going to work gets at this very instance. Now, the third law is when you have powers to powers and you multiply. This fourth thing down here isn't a law of exponents, but rather it is one of the core ideas in section 1.6, namely how to convert negative exponents to positive exponents. And let's just go over that really quickly here. You can change the exponent from a positive to a negative or negative to a positive by moving the base and the exponent from one story to another story in a fraction. So for instance, the y goes from the bottom story to the top story in a fraction here, and the negative 2 gets toggled to positive 2. Notice the y itself doesn't change in sign or value. And I'm going to do this one here on the fly. I'm going to take it from the top story to the bottom story. Notice that the base itself does not change. Rather, the exponent toggles in value. It goes from a minus 2 to a plus 2 to a minus 2. Now, in the homework and in the exams, most of the time you're asked to write your answers using only positive exponents. So I really don't want this in the bottom story here. I want to bring it to the top again to make it positive. Notice I already have a y squared up here, and I'm not going to move it. Instead here we'll have a multiplication, negative 8, the base stays the same, and the exponent gets toggled to a positive 2. If you want to see it in terms of the top story and the bottom story of a fraction, we just do that. But this is basically the answer you would submit if this was a problem in your homework. Okay, let's get after the problem itself here. And word of caution here. Everything here, everything, the up and bottom of the fraction are being raised to the negative 1/4 power. And a mistake I see a ton of is the idea here that the assumption by students often that this negative 4 here is being raised to the same power as this x. It is not, and one of the things I want to show you here is a way of handling that. What I do is I put parentheses around the numbers and I show the actual power, and here in this case it's a nominal 1. Go ahead and show that, as that sort of separates it from everything else in the problem. Now, since we have powers to powers, we're going to be doing the third law, which is multiplication. And I'm going to get on the top a negative 4 to the 1 times negative 4, which is negative 4 power. I'm going to have x to the negative 16, and I'm going to have y to the positive 8. On the bottom, I'm going to have 5 to the negative 4th power, and I'm going to have x to the, that's a positive 4, a negative times a negative is a positive, and I'm going to have y to the negative 16th. Now, I'm going to go ahead and, since these exponents here on the numbers are negative, I'm going to go ahead and change the story of these numbers. The 5 is going to come on top, and the negative 4 is going to go to a positive 4. The negative 4 is going to go on the bottom, and the negative 4 is going to go to a positive 4. Now, in terms of the x's here, the bases are the same. We are dividing. Think of this as a minus sign. So what we have here is subtraction. X to the negative 16 minus 4. And now for the y, again, think of the division bar as a subtraction sign, and I have 8 minus a minus 16, and there's your double negative, and 8 minus a minus 16. I can almost guarantee that 20 to 30% of you would write 8 minus 16 here instead of the double negative, which is going to become 8 plus 16, which is going to be y to the 24th. Now the x here is going to be to the negative 20th power. And in terms of simplifying this, 5 is a prime number. It is only divisible by 5 and 1. And of course 4 has 2's that go into it, but no 2's will go into the 5. So this can't be simplified. All we can do is leave it as it is or go ahead and multiply it out. I've got 4 5's. In a sense, what I have here is 25 times 25, or 625. On the bottom, I have 4 4's. It's going to end up positive because the exponent is an even exponent. And what we'll have here basically is 16 times 16. 4 times 4 is 16, and then I have another 2 4's for 16. And so 16 times 16 is 256. Now all that remains to do is to write this in terms of all positive exponents. So I'm going to shift the location of the x base. Everything else stays right where it is. The 625 stays on the top. The y to the 24th stays on the top. The 256 stays in the bottom. And the x comes to the bottom, and the exponent gets toggled to a positive 20. And that is our answer. Okay, I wasn't at my best in this problem, but I hope what I did helps. And I just want to show you here quickly. I typed this problem in beforehand into Wolfram Alpha, and you can see my work here. This division bar separates the top of the fraction from the bottom of the fraction. And these parentheses, the outermost parentheses, show that everything is to the negative 4th power. Notice the answer right here. So a confirmation makes me feel good that we got it right. Okay, be talking to you soon. I hope that helps.